Hello, Assalamualaikum and greetings to everyone. So today we are going to present about gravimetric analysis of phosphorus in plant food. So this is our team members, which is consists of me, Muhammad Hari Adam bin Muhammad Azwa, and one Danish Faisal bin one Eddie Surya. The objective of this experiment is to determine the content percent of P in plant food through gravimetric analysis. So now let's watch the video procedures. Obtain your plant food sample and record the set of numbers written on the label. Number 2, weigh the plant food sample between 3 to 3.5 grams using a weighing paper and transfer the sample to a 250 ml beaker. And number 3, add 35 to 40 ml of distilled water and stir the mixture with a glass rod to dissolve the sample. If your sample does not completely dissolve, remove the insoluble material through filtration. To filtrate, add about 40 ml of 10% MgSO4 7H2O and then add about 100 ml 2 molar of NH3 slowly while stirring. A white precipitate of MgNH4, PO4 and 6H2O will form. Then allow the mixture to sit at a room temperature for 10 minutes to complete the precipitation. Weigh accurately a filter paper. Fold the paper and feed it into a glass funnel. Wet the paper with distilled water to hold it in place in the funnel. Transfer the precipitate carefully and all the solution from the beaker onto the filter paper. Wash the precipitate by adding 2 or 3 times of 5 ml portions of distilled water to the beaker. Then rinse again the precipitate with 2 10 ml portions of 75% isopropyl alcohol through the filter paper. Then remove the filter paper, place it on a numbered porcelain dish and store it to dry for 2 or 3 days on the bench or dry in the oven for 24 hours at 90 degrees Celsius.
One eternity later.
And lastly, when the MgNH4, PO4 and 6H2O is thoroughly dry, weigh the filter paper plus the MgNH4, PO4 and 6HO2. Record the mass and calculate the percent of phosphorus in your original sample.
Hello, my name is Danish Faisal and I will be presenting about our results and data. For the plant food, we use Baja special grade with the percent content of phosphorus is 15%. The mass of sample that we use is 3.4 gram. The mass of filter paper with magnesium ammonium phosphate is 1.7608 gram, while the mass of filter paper is 0.805 gram. So the mass of magnesium ammonium phosphate is 0.9558. So for the calculations, the question asks us to use gravimetric factor and the mass of magnesium ammonium phosphate to calculate the mole of P. To find GF, we need to use molar mass of P divided by the molar mass of magnesium ammonium phosphate. So 30.97 gram per mole over 137.33 gram per mole, we will get 0.2255. So now we have GF and we need to find the mass of P in gram. We need to times GF with the weight of magnesium ammonium phosphate. So 0.9588 is the weight of magnesium ammonium phosphate times with 0.2255 the GF, and we will get 0.2162 for the mass of P. To find mole of P, we need to divide the mass of P with molar mass of P. So 0.2162 over 30.97 and we will get 0.006981 mole. For the next question, we need to find the mole of phosphorus pentoxide. So firstly, we need to find the GF by dividing molar mass of phosphorus pentoxide with the molar mass of magnesium ammonium phosphate. So 141.94 gram per mole over 137.33 gram per mole times with 2, we will get 0.5168. So once we have GF, we need to multiply it with the weight of magnesium ammonium phosphate to find the mass of phosphorus pentoxide. So weight of magnesium ammonium phosphate is 0.9588 times with the GF 0.5168, we will get 0.4955. So once we have mass of phosphorus pentoxide, we will divide it with the molar mass of phosphorus pentoxide. So 0.4955 over 141.94. So we will get 0.003491 mole. Okay, for now, for the question B, we need to calculate the mass and percent content of phosphorus pentoxide in the sample. First, we need to find the mole of phosphorus pentoxide by multiplying it with 0.003491 mole with 141.94 over 1 mole of phosphorus pentoxide. So we will get 0.4955. For the percent of content, we will divide the mole of phosphorus pentoxide with the mass of sample. So 0.4955 over 3.40 times with 100%, we will get 14.57%. Now for the last question, we need to compare the result from the amount of percent content stated on the label of the plant food and calculate the percentage error. To calculate the percentage error, we need to minus our calculated value with true value, then divide it with the true value, then times it by 100%, and the result will be 14.57 minus 15 over 15 times with 100%. So we will get 2.87% of percentage error.
And for the discussion, the experiment exposes students on how gravimetric analysis can be used to determine phosphorus content in plant food by precipitating it as magnesium ammonium phosphate. The P2O5 content obtained was 14.57%, which is quite close to the labeled value of 15%. The small percentage error indicates that the results are acceptable and the experiment went smooth as it is. As for the conclusion, the experiment was successfully conducted by determining the phosphorus content in plant food using gravimetric analysis. Phosphorus was precipitated as magnesium ammonium phosphate, leading to content of P2O5 acquired. The content obtained was 14.57%, while the value labeled was 15%, which is quite close, indicating the experiment succeed, since the actual value might be slightly off compared to theoretical value and can be proven via percentage error obtained, which is 2.87%. And then that might be all from us. Thank you very much.